Hello everyone, my name is Atharva Shrikhande and I am a second year student at Government College of Engineering, Nagpur. First of all, I would like to express my gratitude to Emertxe Information Technologies for providing me with this incredible opportunity to be a part of their internship program. Throughout the course of the internship, I had a chance to work on a home automation solution project, which was an incredibly enriching experience for me. I would like to extend my sincere thanks to Jayalakshmi ma'am who played a crucial role in guiding us throughout the project. I am now going to deliver a presentation on our project. So let us begin. This is the first slide which outlines about the contents of this presentation. During the internship, we were taught about various concepts which include the fundamentals of C++ programming, what is Internet of Things, and about the embedded systems and microcontrollers. We will discuss about these concepts one by one, and then we will discuss about the project, its overview, its objectives, its requirements, the design of the elements, its simulation, and at last, the conclusion. Now we will discuss about C programming. C is a general purpose computer programming language. This programming language is compiled, making it great for IoT projects. It is also the most preferred language for the IoT hardware with low computing power and constrained RAM. Here is the simple structure of a C program. First one is the file header, which consists of the name of the program. It also consists of the author name, data, and other information. Second one is the preprocessor directive. It tells the compiler to process the information before the compilation starts. And this is the main function. Main function serves as the starting point for the program execution. Within the curly braces is the main body of the program. The first one is the comment statement. The second one is the simple printf statement, which prints hello world here. And the last statement is the termination of program, that is return 0. Topics covered in C++. During our internship, we learned various topics such as data types. Uh, Various data types are int, float, double, etc. We also learned various operators such as arithmetic operators, logical operators, etc. and conditionals, which include if else statement and also else if statements, and loops, which include for loop, do while loop, and while loop. Then we also learn arrays, which is used to store elements with similar data type. Then function, which is a group of statements that together perform a task. Pointer, which is used to store address of another variable. String, which is a sequence of characters. And then we also studied storage classes, preprocessing, and at last we were taught about the basic concepts of C++ language. Now, next, what is Internet of Things? Internet of Things describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and system over the internet. Here in this picture, you can see a single tablet is used to control various devices which are connected to the internet as well as cloud. Now, IoT architecture. This image is of IoT architecture. The first section is of device connectivity, where the IP capable devices, mean the devices which can be connected to internet, are connected to the cloud with the help of the gateway. The next is data processing and analytics, in which the data is processed and analyzed. And the last section is of presentation and business connectivity. Examples of IoT include home automation, smart TV, smart car, and a well-renowned example of IoT device is Alexa, which is used to control various devices in our home. Applications of IoT. IoT is applicable in various fields such as healthcare, automobile, smart city, etc. Now, what are embedded systems? Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. It consists of firmware, hardware, and software. This is the simple structure of the embedded system. It consists of a sensor, analog to digital converter, processor and ASIC, memory, digital to analog converter, and actuator. Now, embedded system components. This is a more precise image for the architecture of the embedded system, which contains all the components. Various components includes actuators, digital to analog converter, memory, which is RAM and ROM, FPGA, ASIC, that is application specific integrated circuit, diagnostic port, human interfaces, analog to digital converter, sensors. These all components are connected to the microprocessor or microcontroller, and this whole system is connected to the software. The examples of the embedded system include automobiles, mobile phones, industrial machines, medical equipments, and this image shows some more examples of the same. Now the next is microcontroller. A microcontroller is a small and low-cost microcomputer which is designed to perform the specific tasks of embedded systems like displaying microwaves information, receiving remote signals, etc. It contains analog to digital converter, digital to analog converter blocks, PWM, that is pulse width modulation, control counters and timers, processor, memory and input output parts, microprocessors and SoC, ROM, RAM and its types. Types of ROM include PROM, EEPROM, and masked ROM. Types of RAM include dynamic RAM and static RAM. Now we will start discussion about the project. Project's overview. This project provides an IoT-based home automation solution using Arduino Uno board in Pixim Lab Simulator. Blynk IoT mobile application is used to control the devices via cloud. This project includes three systems. The first system is to control the garden lights as per the availability of the sunlight. The second is to control the temperature of the home. The third is to control the inflow and outflow of the water in the water tank. Now the project's objectives: connect all the device to Arduino, that is Pixim Lab Simulator, and integrate it with the help of Blynk IoT app using cloud. Control garden lights automatically to check real-time status of water level in tank and temperature of the room with the help of Blynk IoT app to obtain notifications regarding their status. Now, what is home automation and its need? A home automation system typically connects control devices to smart home hub. The user interface for the control uses the mobile phone application or web interface that may also be accessible off-site through the internet. When we are away from home, we are not able to monitor our home appliances, but with the help of home automation, we are able to check their status just by looking at our phone. This reduces the risk of any appliance malfunctioning and helps us to keep our home safe. As you can see here, this image by simply integrating the Arduino board to the Blynk cloud server and also to the Blynk IoT application, we can transform a simple home into a smart home. Now, what are the requirements for this project? The requirements are Arduino Uno board, LED and LDR, temperature sensor, and the temperature sensor used here is LM35, CLCD, that is character liquid crystal display, Ethernet shield, which is used to connect board to the internet, cooler, heater, and serial tank, which is connected through serial communication. And the software tools required here are Arduino IDE, Pixim Lab, Virtual Serial Port, and Blynk mobile application. Now, this image is the image of architecture of the project. Here you can see the Arduino Uno board is connected to various parts such as LED, LDR, CLCD, temperature system, Ethernet shield, and the serial tank is connected through the serial communication. And all these spare parts are connected to the Blynk cloud with the help of these virtual pins. Now next is Arduino Uno. Arduino Uno is based on an 8 Mega 328P microcontroller. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input-output pins, shields, and other circuits. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an ICSP header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. It can be programmed using different IDE, that is Integrated Development Environment. Here for this project, we have used Arduino IDE, which supports C and C++ languages. This image shows the Arduino board. Next is Pixim Lab. Pixim Lab is a real-time emulator of development boards with MPLABX debugger integration. Our program written in Arduino IDE is saved as an hex file which is loaded into PiximLab in order to program board's microcontroller. It contains Arduino Uno board and other various spare parts required for this project. Next is Blynk IoT application. Blynk was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. Various steps involved in setting up Blynk mobile application are create template, add devices, add data streams, create icons, include Blynk library. Now, the next part is CLCD. CLCD is a character liquid crystal display which displays alphanumeric and symbols or characters. It displays ASCII characters up to 16 characters. This is the image of an CLCD, serial remote tank. Serial remote tank in IoT refers to a system that enables the remote monitoring and control of tanks or other containers using a serial communication protocol. This system involves the installation of sensors on the tanks to collect real-time data on various parameters such as liquid level, temperature, pressure, and flow rate. This allows for remote monitoring and control of the tanks from anywhere, as well as alerts and notifications if certain conditions are met or exceeded. This is the image of the serial remote tank. Next is LDR, that is light dependent resistor. An LDR is a component that has a resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The LED lights are connected to the LDR via the ADC. Analog to digital converter converts the analog input received from the LDR into its equivalent digital form. This digital value is then converted using a certain formula to range between 0 to 255 as the upper bound, which is then used to determine the appropriate brightness level for the LED lights. LDR is a resistor whose resistance varies according to the light intensity. Here you can see the LDR's relation with the sunlight. If the sunlight is maximum, resistance is minimum, and the voltage is maximum, and the LED will be turned off. If the sunlight is less, resistance is maximum, and the voltage is also minimum, and the LED will turn on. Now, this is the first system, that is garden lights control system. The property of the LDR to vary its resistance based on the intensity of the sunlight is utilized to control the brightness of the garden lights. During the day, when the outdoor light is at its maximum, the LDR sensor detects this and the garden lights are turned off. Conversely, during the night, when the outdoor light is negligible, the LDR sensor detects the low light levels and turns on the garden lights to an appropriate brightness level. As in this image, you can see that the LDR sensor detects the light and sends that information to the Arduino Uno, and the Arduino Uno in turn controls the lights. That is, the intensity of light is controlled by the Arduino Uno. Moving on to next slide, the slide tells us about temperature sensor. The temperature sensor is a device that detects and measures hotness and coolness and converts it into an electrical signal. Here in the project, we have used LM35 sensor to measure temperature. LM35 reads analog values only. The value is converted into binary value, and the latter actual temperature is calculated using the obtained value of the voltage. In Pixim Lab, the LM35 sensor is positioned within the temperature section spare part together with a cooler and a heater. This is the image of an LM35 sensor. Now the second system is temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler which resembles the temperature control system at home. The temperature is read from the LM35 sensor and displayed on CLCD. Notifications are also displayed on CLCD. The temperature of the system is controlled by turning on off the heater and cooler button through the Blynk IoT mobile application. Here the temperature once reaches 35 degrees, the heater turns off automatically and maintains the temperature at 27.34 degrees Celsius. This is the diagram for the temperature control system. It contains Blynk IoT application, Arduino Uno board, CLCD, and temperature system. The temperature is read from the temperature system and that information is passed on to the Arduino Uno and then to the Blynk IoT application. The Blynk IoT application is used to control the heater and cooler, and that information is passed on to Arduino Uno and then to the temperature system. And according to need, the heater and cooler are turned on or off. The Arduino Uno displays notifications and temperature value on the CLCD. It as well as displays notifications on the Blynk IoT app. The third system is water tank inlet and outlet valve control system. Here volume of the water in the tank through serial communication is read and displayed on the CLCD along gauge on Blynk IoT app. Volume of the water in the tank is controlled with the help of inlet and outlet valve by sending commands through serial communications with the help of Blynk IoT app. Here the level of water is continuously monitored, and if the level goes down 2000 liters, then the inlet valve is instantly turned on, and if the tank becomes full, the inlet valve gets turned off. This helps to maintain the level of the water in tank and reduces the chances of water wastage. This diagram here is of the system. It contains Blynk IoT application, Arduino Uno board, CLCD, and water tank. The volume of the water is read from the water tank, and that information is passed to Arduino Uno and then to the Blynk IoT application. The Blynk IoT application controls the inlet valve and outlet valve and send that information to Arduino Uno and then to the water tank. And according to need, the inlet and outlet valve are turned on or off. Then the Arduino Uno board displays notifications and volume of the water on the CLCD. It as well displays the notifications on the Blynk IoT application. Now this is the project simulation image. This pair part is the CLCD. It displays the temperature. It also displays the volume. It displays whether the heater or cooler is turned on or off. It displays whether the inflow or outflow is turned on or off. The next is the LED. The next part is the LDR. And the next part is the Ethernet, which is used to connect the Arduino Uno board to the internet. Next is the temperature control system. It contains the heater, the cooler, and the temperature sensor, that is the LM35 sensor. This is the Arduino Uno board, and this is the serial remote tank, which is used for the demonstration of the water level in the tank. And all these parts are connected to the Arduino Uno board. The last slide is about the conclusion. Main purpose of home automation system is to provide ease to people to control different home appliances with the help of the Android application present in their mobile phones and to save electricity, time and money. Using Blynk IoT application and Pixim simulator, simulated home automation where LED temperature system serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from the Blynk IoT app like button widgets are used to control heater, cooler, and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. This project provides perfect solution for the home automation. Home automation offers a futuristic way of the life in which an individual gets to control the entire house using a smartphone or watch, from turning on a TV to locking or unlocking doors. It also offers efficient use of energy. So this was all about the presentation. Thank you. Now I am going to explain the code that we have written for the home automation project. So I have opened here the Arduino IDE where we have created separate files, so it will be easy to maintain them, and we will see each file one by one. So the first file is the main file. In the start we have defined here various macros for the Blynk authentication token, template name, template ID, which we will get after we register on the Blynk cloud. Then after we have included various libraries required for the Blynk as well as for the CLCD, and we have included all the .h files here. We have initialized various variables, and we have also written various functions. The first function here is for the cooler VPN, uh, which is used to turn off or on the cooler. If the cooler is on, the message cooler on will be displayed on the CLCD. If the cooler is off, the cooler off message will be displayed on the CLCD. The next function is for the heater VPN. If the heater is on, Heater on will be displayed on CLCD. If the heater off will be displayed on the CLCD. The next function is for the inlet VPN. If the value of the inlet switch variable is true, then we will enable the inlet and inflow on will be displayed on the CLCD. If the value of the switch is false, then we will display inflow off on the CLCD. And the same is for this function outlet VPN. The next function is of update temperature reading. This function is used to display the real-time temperature and volume on the Blynk IoT application with the help of the gauge. The next function is handle temp, which is used to handle the temperature. If the temperature is above 35 degrees Celsius, the heater will automatically turn off and this message will be displayed on the notification bar of the Blynk IoT application. The next function is to handle the volume of the water in the tank. If the volume of water is below 2000 liters, the inlet valve will automatically turn on and these messages will be displayed on the Blynk IoT application. And if the volume is full, the inlet valve will automatically turn off and these messages will be displayed on the Blynk IoT application notification section. So now the next function is the setup function in which we have called various functions and all these functions will be called only once. The first function is to configure the garden lights as output. Other functions include init function to initialize the LCD, the temperature system function to initialize temperature system, the serial tank function to initialize the serial tank. The last function here is the loop function in which all the functions here will be called repeatedly. So this was all about the main file. The next file here is the main.header file in which we have defined various macros such as on, off, temperature gauge for which we have defined the virtual pin V1, for cooler V0, for heater V2, for water volume gauge V3, for inlet V4, for outlet V5 and for Blynk terminal V6 which is used to display the notifications on the Blynk IoT application. The next file is ldr.header file in which we have defined macros such as LDR sensor and garden light and also declared some functions such as init LDR and brightness control function. The next file is ldr.cpp file in which we have defined the init LDR function which is used to configure the garden lights as output. The next function is here brightness control function which is used to control the brightness of the garden lights. The next file is temperature system.header file in which we have defined macros such as heater, cooler, temperature sensor and also declared some functions. The next file is temperature system.cpp in which we have defined the function init temperature system which is used to configure the heater and cooler pins output as well as to turn off the heater and cooler. The next function here is read temperature function. In it we converts the analog value into the voltage and that convert into temperature and return that temperature. The next function is cooler control, which is used to control the cooler. And the next function is heater control, which is used to control the heater. The next file is the serial tank.header file, in which we have defined various macros such as inlet valve, outlet valve, high float, low float, volume, enable and disable, and declared some functions. The next file is serial tank.cpp file in which we have initially declared some variables and then defined the init serial tank function. It is used to begin the serial communication between serial tank and the Arduino board. Next function is the volume function which is used to read the volume of the water in the tank. The next function is enable inlet which is used to enable the inlet. Next function is used to disable the inlet, enable the outlet, and the last one is used to disable the outlet. So this was all about the code. Now I will compile this code. Here you can see the compiling is done and it is successful. So there are no errors in this code and the hex file can be loaded into the PixSimLab. Now moving ahead, I will give you the demo of the project that I have made. Here you can see the PixSimLab and I have opened the spare parts window of the PixSimLab. Here there are various spare parts which are connected to the Arduino Uno board. The first spare part is the CLCD. The CLCD here is used to display the temperature, and the current temperature displayed here is 27.34 degrees Celsius. It is also used to display the volume, which is 3000 liters. It also displays whether the cooler or heater is turned on or off, and it also displays whether the inlet or outlet valve is turned on or off. The next spare part here is the LED. Here you can see the LED is connected to the GPIO pin 3 of the Arduino Uno board. The next spare part is the LDR. LDR stands for light dependent resistor. As the name suggests, the resistance of the resistor depends on the amount of the light falling on it. The next part is the ETH-W5500, that is the Ethernet shield, which is used to connect the Arduino Uno board to the internet. The next spare part is the temperature system. This temperature system spare part contains heater, cooler along with the temperature sensor. The temperature sensor here used is the LM35. This LM35 temperature sensor detects or sends the temperature and displays that value on the CLCD. And here you can see the Arduino Uno board, and this is the serial remote tank which is connected to the serial port COM2. And here you can see the tank currently is filled completely. Now I will tell you about the first system, that is the garden lights control system. This system consists of two spare parts. The first one is the LED and second one is the LDR. Here you can see if I decrease the resistance of the LDR, the intensity of the LED will decrease, and if I increase the resistance of the LDR, the LED will turn on. This implies that during the day, when the daylight is more, the LED will turn off, and during night, due to the lack of light, the LED will turn on. Now I will tell you about the second system, that is the temperature control system. For that I need to mirror my phone. Here you can see I have mirrored my phone, and in it I have opened the IoT Blynk application, which is connected to this system with the help of various virtual pins and also with the help of this Ethernet shield. Now the spare parts required here are the CLCD, the temperature system, and the Ethernet shield. In this application you can see there are two buttons. The first one is for the cooler, the second one is for the heater, and there is also a temperature gauge to show the temperature value, and also a notification box to show the notifications. Now if I on the heater, here you can see the temperature is rising, and also it is showing the heater is on. The temperature will rise up till 35 degrees Celsius, and the heater will turn off automatically. And a notification is shown, that is temperature is above 35 degrees Celsius, turning off the heater. Now if you want to decrease the temperature at a faster rate, simply turn on the cooler. Here you can see the temperature is decreasing at a faster rate, and also showing the cooler is turned on, and the fan is rotating here. Now the temperature is reached at 27.34 degrees Celsius. Even if I turn off the cooler, the temperature remains the same because it is the standard room temperature. Now the third system is water tank inlet and outlet valve control system. This system consists of spare parts such as CLCD and serial remote tank. It also requires the IoT Blynk application, which is used to control this system. Here in this remote tank, you can see that the tank is currently filled completely with water, and this is the inlet valve and this is the outlet valve. Now we need to go in the tab 2 of the application. Here in tab 2, you can see that there are two buttons. The first one is for the inlet valve, and the second one is for the outlet valve. And there is also a volume gauge to display the volume. Now, when I turn on the outlet valve, you can see that the volume of the water in the tank is decreasing, and it is also shown here that the outflow is on. When the volume reaches 2000 liters, the inlet valve will turn on automatically. Here you can see that. Now, if I turn off the outlet valve, the volume of the water in the tank will start increasing, and here it is shown that the outflow is off. When the volume reaches 3000 liters, that is the tank is full, the inlet valve will turn off automatically. And the notification you can see here, the displayed notification is volume of water in the tank is less than 2000, turning on the inlet valve. And the second one is for like a volume of the water in the tank is full, running off the inlet valve. So this was all about the project. Thank you.